Hello students, welcome to the Yupp Master. Today we are going to learn the interesting topic on dimension analysis and dimensional formulae. But at the early stage we are going to discuss about all these things. So how you are going to crack the examinations, entrance examinations. Now if you are about to write that examinations after your 10th class, now you are in the 8th class, you have to learn a little bit about the previous one. Now they have included in +1 actually, but at earlier time you are going to know about these all important formulas and applications. You feel better, right? It's good to learn, right? Let's have a look. Dimension analysis. Already we have discussed about the dimensions and dimensional formula, how we can represent the dimensional formula with the base units and its conversions, and all these are we have discussed. Now we are going to frame the different problems based on the previous competitive examination blueprint. They will ask, surely they will ask the questions from this topic, no doubt at all. Let's have look into matter of that related problems based on the dimensional analysis and dimensional formula. You know very well about that. So why you are going to take that? Yeah, please take that. Yes, if you are going to take that dimensional analysis, you can take that representation of one quantity in terms of the fundamental quantities. So the power of the quantity has been raised to derive that derived quantity. Simply the dimensional formula is nothing but the representation of the raise of power of the base quantities, which are going to be represented by their symbols in SI system. They have 7 symbols are there to represent the base quantities, right? Okay, let's see that. If you are going to take that, the representation is nothing but any quantity that is going to be measurable quantity, it can be represented as m power L power T power plus or minus A plus or minus B plus or minus C. It's very clear. Here A is positive, negative or 0, like that. B is also positive, negative or 0. C also. It's very clear. Now what do you mean if you are going to identify that? Suppose you have been taken one relation, left hand side and right hand side. Both are going to be compared with the dimensional analysis. Let's see. Principle of homogeneity is the first one. If you are going to take that, homogeneity is the same kind of rule applied to left hand side and right hand side. That's nothing but comparison. You are going to apply the same rule, that is called homogeneity. Now let's take that according to this principle. When do you say if the dimensional equation is correct? You are going to represent that one physical quantity in terms of the base units. How you can say it is dimensionally correct relation? So on the right hand side and left hand side, if you are going to take that, each and every term is going to be having that same dimensions. It's going to be having that, dimensions of the fundamental quantities are the same in each and every term. Suppose I have taken that this is A and B and C. I have been expressed that A and B are of same with A. So you can take that dimensions of B should be matched with A, dimensions of C should be matched with A. How you will take that homogeneity principle in the better way for your understanding? If you are going to take that one task, testing of your blood sample easily, they may took that blood in terms of drops, not others. Okay, simply let us assume they have taken in the diagnostic center, they have taken the blood of one drop. Okay, it's very clear. They are about to check the blood from different parts of your body or one part of your body. Tell me the answer. They are going to take the blood from your right hand, left hand, leg, right leg, left leg. They will take the blood from any part. It has that same composition. In order to estimate that culture, in order to estimate that nature of that blood group and all about its, they are going to take one drop from any part. Like that, if you are going to take the blood from any part of your body, it is having the same nature. It possesses the same nature. That's what you can understood that principle of homogeneity in a better way. Even though right hand times that just you have to take that many of the terms are there. Just you have to take, yeah, it's going to be expressed as P, D and E, whatever it may be. This is of your total body, whatever it may be. They have taken any part, they have taken any part. They have that same, they have the same nature. That's what you are going to know about this one, this one, this one, this one. It's very clear. That's what you can understood very easily, the principle of homogeneity. At the same time, you can take that. If you want to add the term, what you will see? Suppose a B positive person is there. Can you assess that? Other same. It is going to be having the same kind. Then only you can add. You can give that. You can donate. Until a special case is there, that is universally donor. That is a special case. But you are going to look into that matter of that homogeneity. If you have taken the blood from different parts of your body, they are going to be same composition. It's very clear. Suppose you have taken one equation which is dimensionally correct. On left hand side and right hand side, we have to take the different terms. The derived quantity can be expressed in the form of different terms. Summation of different terms, subtraction and multiplication, whatever it may be, that you have to get this. The homogeneity has been applied. Very clear. I hope so you have been understood very well. Once again, I am going to convey in a short form. Very simple. You are going to take that. On the left hand side, you have been written the derived quantity. On the right hand side, it has been expressed in terms of different physical quantities, A, B, C, like that. They are also having the same dimensions with respect to this derived quantity. They are of the same kind of this derived quantity, then only we can add, then only we can subtract, then only we can represent as a summation, as a subtraction, whatever it may be. Suppose A is equal to B minus C. B and C both are having the same nature. That is very clear. Like that, I have been explained that taking the blood sample from the different parts of your body. No doubt at all. Very good observation. Now let's go for another one. Yeah. Its application. Principle of homogeneity. We have discussed about that. Based on the fact only the quantities A, B, C, they are related. A is equal to B plus C. If you have been find out that D is a one kind of that physical quantity which is having the same dimensions of A, then you can write A is equal to B plus C plus D also, no doubt at all. That's very clear. So this is the dimensionally correct, which is having that B and C are having the same dimensions of A. That's what we are going to apply that addition, summation. We are going to express that in the form of summation, in the form of addition and multiplication also we can take that. Yeah, it's very clear. We are going to have that having the same nature. Similarly, sum of B, C can be equated to A if they are like quantities, unlike quantities and like quantities. If they are going to be like quantities, we are going to have that. They must have the same nature. That is the reason we are going to write A is equal to B plus C. Right, let's go for another one. Yes, you can take that. Check the correctness, whether they are going to have that correct relation or not. If they have been expressed as a summation, very clear. That is the principle of homogeneity of the dimension is possible. Right, let's go for another one. Yeah, applications of dimensional formulas. It is useful to convert one system of units into another system of units. Right, very easily you will write down that. Therefore, N1 into M1, L1, T1, A, B and C. You are going to convert into another system, that is, yeah, you will take that N2 into M2, A, L2, B, T2, C. It's very clear. Suppose if you are going to take that, N1 is the value, N2 is also value. If you want, you can get that. 1 Newton is equal to, if you are going to take that, 1 Newton is equal to 10 to the power of 5 dyne. How it is going to be expressed? Let us see that. So, if you are going to take that conversion, 1 is the value. If you are going to take that kg, meter second, so it is also gram. So, this is the CGS and this is the SI system. Easily we will find out that CGS system and SI system we can discuss. Yeah, right. Now you can take that another one. Yes, let's go for second one. To check the correctness of an equation to derive the relation among the physical quantities. Let us have that one derived quantity Q. These are all having that relation Q1, Q3, Q, right. So, you know very well about that, how you will represent that relation among all these things. Q is equal to some k power n into Q1, Q2, Q3. Just you can take that, you can represent very easily. In order to derive the relation, simply Q1, Q2, Q3 are having the relation with Q1. You are going to represent in terms of some constant. So, it is very clear. Now, let us have a look into another one. One best problem we can take that. This is a problem. So, what we are going to take that, this is the velocity of a particle V at instant time t is given by, the velocity has been represented by that AT, summation of first term and second term, we have taken that. Yes. Now, what are the dimension of B? That is very clear. Now, let us go for that. V is equal to AT plus BT square, that is the case. Now, let us have a look. This is A, this is B and this is C, let us assume. So, we can take that dimensions A, B, we have to take that A is equal to B and A is equal to C, we have to take that, then only this equation is correct. Now, let us have a look, we have to find out that B, we have to find out that constant B. Yeah, if you are taking that, you know dimensions, that is L by T is equal to, if you want to calculate that B dimensions, just you have to take that B T square, B T square. You can represent, that is L by T is equal to B T square. We will take that T square. Now, you can easily find out that, therefore, L by T cube is equal to B. That implies B is equal to L power L T power minus 3. That is very clear. Now, if you are going to have the look, that is B is equal to, dimensions of B is equal to L T minus 3. Very clear. If you are going to take that, this is very clear. Let us have, yes, let us take that, this is the correct one. How it is possible? Just you have to take that principle of homogeneity. You have been applied that principle of homogeneity. Yeah, this is the case we can confirm. Suppose additional information is required. So, you want to calculate that A value, what can you do? You have to use this equation. This is the first one. This is the second one. What happened if you are using this second relation? Please take that. Yeah, let us have that. If you are using this relation, yes, if you are using this relation, what happened? Let us see. Yes, we have been find out that B is equal to, yeah, we have taken B is equal to L into T minus 3. So, this is the expression that we are using, A is equal to C. This is the one case. If you have been used that A is equal to B, what happened? Let us see. A is equal to B, let us happen. So, where A is equal to B plus C, we are using this one, very simple. We have taken that A is equal to B, that is V is equal to AT. We have been represented in terms of dimensional formula, that is, you know, velocity is equal to displacement by time, yes, easily we can write down displacement. It has been represented with that base quantity L, it has been represented time. So, that you can write down L by T is equal to A into T. Just you have to use this one, right. Now, it is very clear for L by T is equal to AT, therefore, A is equal to L by T square. So, that is L T minus 2. That constant has been evaluated, that is L by T square. So, finally, how you will check that? Let us have that checking. Yes, if you are taking that, yeah, if you are going to substitute V is equal to A T plus B T square, just you can put that A value, A, V is equal to, what is A value? Please let us have a look, L by T square into T plus L by T cube into T square. So, you have been written in terms of that expression, that is finally you will get that V is equal to L by T square into T plus L by T cube into T square. So, you are going to cancel that terms, yes. Now, finally, what you are getting that V is equal to L by T plus L by T. So, L by T is equal to L by T plus L by T. Finally, we are having that representation, it is very clear. We have been verified This is A, B and C. In this way we will approach for any problem. They have given any kind of that relation, the derived quantity has been expressed. Finally, we have obtained or not? Let us see. Yes, you have to take this one. Right. So, if you are going to have look, this is the case, this is the rough work what we have done. After the substitution we have been verified. So, this is verified dimensionally correct relation. You can take that. So, it is the correct relation. Yes, it is very clear. If they have given any kind of that problems, you can easily solve that. Yes. So, let us go for another problem. Yes, it is very clear. You are going to take that this x value is going to be calculated. Very clear, just you can observe that. Now, if you are going to take that relation, then the value of x is what? Yeah, you know very well. So, while you are going to solve this problem, later we see. Yeah, if we are going to take that dimensional formula. If they have related correctly, then we can easily find out that x value. Yeah, for force, you can take that force that is equal to mLT minus 2. We can take that. Yes, and it is going to be identified that for mass, yeah, you can take that for mass, you can take that m, length, you can take that L, and the time, you can take that T, time period, we can take that T. These are all the relations we are having that. Now, let us have that force. Yeah, you can take that relation. Yes, you can take the relation and get the substitution. Easily you will find out that. Yes, if you are going to take that M, L, yes, easily you will find out that force power x is equal to mass square length square by time period whole power 4. Very simple, you can take that ml yes, you can take that ml t power 2 minus 2 whole power x is equal to m square L square by t power 4. This is very clear. Now, finally, you can get that m square L square t power minus 4, and you can express that is m L t power minus 2 whole power 2. So, ml t minus 2 whole power x is equal to. So, we are going to get the equation. Yes, one more substitution we have been written, that is m L t minus 2 whole power 2. They are related. So, the bases are going to be having that comparison, then they are equal. You can get that powers, then x is equal to, then x is equal to 2. It is very clear. You will get that first equation. Very simple basic questions. As compared to the first one, this is very simple. You can solve that. Yes. have the observation, that is 2. We are going to write down, we have to define that, yeah, this is defined, this is also very clear. Let us go for another one, matrix match type, very clear. So, okay, we are going to calculate some dimensional formulas and the dimensions also. Right, you can take that. First one is spring constant. You will take that, yeah, spring constant. If you are going to take that one spring, it is going to be having that, it is attached by the mass. So, it is having that relation F is equal to minus Kx, okay, it is going to be having that. We are going to ignore about the sign, yeah, K is equal to F by X, K is equal to F by X. So, it is one case we are going to take. F, X, it is going to be represented with the L. Therefore, M L T minus 2 by L. Yes, you can take that M L power 0 T power minus 2. What we have obtained, that is M power 1. Yes, please take that M power 1, L power 0, T power minus 2. Yes, I hope so. This is that very clear. And next one, if you are taking that Pascal, that is you are going to take that, yeah, pressure. We are going to take that. We are going to take that pressure, that is equal to force by area. We are going to take that force by area. Simply you can take that M, it is a unit for that pressure, and you will identify that T minus 2 by L square. So, you will get that, yeah, M L power minus 1 T power minus 2, M L power minus 1, M power 1 and L power minus 1 and T power minus 2. If you are going to take that, this is very clear. Hertz, it is going to be identified that, yes, you will get that for the frequency. If you are going to take that Hertz, yeah, number of, it is going to be identified very easily, only that, yes, we will take that, yeah, it is going to be 1 by T. Just we will take that T power minus 1, that is M power 0, L power 0, T power minus 1. This is, Hertz is the unit for the frequency. Just, it is going to be reciprocal of the time period, and time period it is going to be identified that time taken to complete that one revolution. It is going to be reciprocal of time period, that is frequency. It is very clear. Now, what about the third one, fourth one, Joule. You know very well about that, Joule. It is a unit for energy. Yes, you can take that. So, the representation of energy is in terms of joules also, that is taken in SI unit. Now, you can take that E is equal to, whether you have taken that potential energy or kinetic energy, they have not given. So, in this case, we have to calculate that. Let us erase some part. Yes, we will take that all erase. Yeah. Now, we will have to get that relation has been identified. Therefore, Joule is that energy. If you are going to get that representation, Joule is, now you will take that either potential energy you can take that potential energy or kinetic energy. Let us discuss that. If you are going to have that potential energy, due to the virtue of the state at a definite position in the space, there exists a potential energy. So that is equal to mgh, that is equal to half mv square. Very clear. Now let's have a look. So mgh, that is represented in dimensional formula. G is the acceleration due to gravity. So m L by T square and L. So m L square T minus 2. It is 1, we know that. And next one, kinetic energy, that is you can take half mv square. It can be represented as m into L by T whole square. Why we are going to get that velocity? It is displacement by time. Already we have discussed, that is ml square T minus 2. ml square T minus 2. Just you can take that. This is the first one. And we have taken H. This is, yes, and spring constant, that is F by, yeah, you can take that F is equal to spring constant. Simply you will find out that F is equal to minus Kx. K is equal to F by x, that is mlt minus 2 by L. You will take that m power 1, L power 0, T power minus 2. That spring constant L power 0, T minus 2. It's going to be like that. That Pascal, it's going to be identified that, yeah, you can take that F by A. You will take that F by A. This is the pressure. We can take that pressure. Yes, that is force by area. We will take that. If you are going to take that, it's very easy. So this is about the representation. Yeah. Let us go for another one. Easily you will find out that is m L T minus 2 by L square. You will take that upon L square. You will get that is m L power minus 1 T power minus 2. Yes. Yes, m power 1 L power minus 1 T power minus 2. This is the correct. Okay. If you are going to take that any of the derived quantity, it has been represented in the base quantities in terms of its formula. You need to identify that formula related to that derived quantity, and that you can easily find out very easily. Right. Let's go for another one. Yeah, pair of quantities have the same dimensional formula. You are going to get that force and power, all these things. Let's have that. Look, momentum and impulse. Impulse is the one which can give that large amount of force will act in the small interval of time. That is the impulse. Or rate of change of momentum, that gives the impulse. Very clear. So, you know, momentum, that is, yeah, it is identified, momentum and impulse. We can take momentum, that is mv, that is mv. Yeah, it's very clear. Now we can take that impulse. Yes, impulse is nothing but force into time, or you can easily find out that change in momentum. You will find out that very clear. So, if you are going to take that expression m into b minus u by t into t, just you can cancel the term very easily. You will get that change in momentum mv, yes, you will get this, that is equal to mv minus mu. Very simple, you have been obtained from this one. Okay, I think so. These are all having that same. Here you will get that this is delta p, change in momentum. Here we know very well this is m L by t. So, that is equal to ml t minus 1. Here also ml, you will take that ml t minus 1. Yeah, impulse and these are having the same physical quantities, we have been checked it. But you, apart from that, you need to know about impulse. The case we are going to hammer to grip the nail into the wall. That hammer has been taken, it has been applied. Yeah, this is very clear. We are going to hammer it with a large amount of force. This is the hammer. Let us assume this is the hammer, this is the wall. It's going to be identified that. Here, large force is acting in the small area. This is the small area. Within the small area, within the short period of time, large amount of force is acting. So, there exists an impulse. It is very clear. If you are going to take that another one also, you can check it very easily, you will check it. It is very clear, I hope so, from that momentum and impulse, right. Now, let us go for answer. It is very clear. Momentum and energy, you can easily find out that. For momentum, if you are going to take that these set of values ml t minus 1, ml t minus 1. Suppose you are going to take that ml t minus 1, energy ml square t minus 2 and ml square t minus 2, and you can take that pressure force by area. Pressure is equal to force by area, that you will take that m L minus 1 t minus 2. You can take that, and force you will take that ml t minus 2, and power, that is w by t, that is f dot s by t, that is ml square t minus 2 by t, that is ml square t minus 1. Yeah, at any cost they are all having that different. This is not equal, these are not equal, and these are also not equal. So, first one is the correct one. If you are going to check that answer, it is very clear. So, all of you have a nice day. Keep watching all these classes.